Hello, my name is John Hallman, the Product Manager for Trust and Security at OneSpin Solutions, and the topic of our poster is Automated IP Trustworthiness Assessments for Hardware Assurance. I'm speaking on behalf of our partners at the Aerospace Corporation and my colleagues here at OneSpin. Our goal is to provide IC integrity solutions to develop functionally correct, safe, secure, and trusted integrated circuits. The use of semiconductor IP in our integrated circuits is essential in the world today. IP has the benefits of saving design effort, but also comes with its share of risk. IPs may come from many different sources, some in-house and others from third parties, often from organizations globally distributed. Using IP from unvetted or unfamiliar sources comes with the risk that the IP may include security vulnerabilities or undocumented logic, or even worse, malicious functions. IP offers an easy opportunity for an attacker to insert a hardware Trojan or backdoor into your design. For security and safety critical missions, the risks to the ICs with this IP must be managed appropriately. At OneSpin, we are working on automated analysis tools for assessing the trustworthiness of IPs. Utilizing technologies for structural analysis and formal verification, we perform automated checks that raise the confidence in the IPs under test. We leverage experience, building the knowledge of known Trojans and suspicious code patterns into tools in order to perform initial detections. We identify unexpected interactions between logic functions and reduce the complexity of proofs through intelligent analysis techniques. Finally, automatic mathematical reasoning with advanced formal engines can help prove the absence of Trojans. Along with our partner Aerospace, we have tested over 90 designs of varying size and complexity with and without Trojans inserted. Early results have been very promising. The table shows a representative selection of IP analyzed, the automated runtime, and the issues reported and detected. We've reported a few trigger issues, successfully avoiding unnecessary false alarms. Reliability issues are more frequently reported, as this logic will typically be removed by synthesis or later design optimization steps. However, leaving this logic unchecked and in the design could certainly be an avenue for later exploit. In general, runtimes are short. However, this is not necessarily meant to be an iterative run, so a few longer runtimes are generally not a major concern. Many of the Trojans that our detection methods have uncovered include detecting the triggering mechanisms used to activate an undesired function. Characteristics of these triggers include those based in deep counters, sequences of events, or the use of finite state machines to monitor specific data conditions. In the example shown in the poster, we highlight the source code where our detection method identified the monitoring of 3 different values on a data bus. We quickly interpret that this is when the function receives the data values AA, F0, and 0F, and then an enable signal would activate some other piece of logic. In this case, we quickly trace the enable to what turns out to be a power wasting register. The assessment report view consists of a unique ID and several properties for each of the issues identified. When selecting the unique ID, a debug environment consisting of highlighted source code and a waveform counterexample are demonstrated for the user. A severity level has also been provided to help the user assign priority order to address the issues. While not yet automatically populated, this field has a great potential for intelligent population in the future. The report is a useful view in graphical mode, and it also can be easily exported to text with a simple click. In summary, IP trustworthiness is a growing concern with the increased use of in today's complex SoC designs. A vulnerability or Trojan at any level, including down at the IP, can compromise the security of an entire system. What is needed is an automated trustworthiness assessment, one that provides with low effort, objective approach that increases the confidence in the IP being used. One that does not require additional IP models or detailed IP knowledge. As new vulnerabilities, weaknesses, or Trojans are discovered, new detection methods will also need to keep up, so the platform must be open to continuous improvement. We also must keep the noise level down. let's report only what we're sure of and not chase the red herrings, avoiding those issues that have plagued earlier tools such as the original linters. While we still have some limitations as the security community continues working out the trustworthiness metric, we still can detect many Trojans. But we can't necessarily prove the absence of all functional Trojans. However, this should not deter us from taking action now. Let's raise the bar on how difficult it is to affect our microelectronic components and do our part to improve the security of our ICs. Thank you for your attention in reviewing the work performed here with our partner at Aerospace. If you want to learn more about automated trustworthiness assessment of third-party IPs or looking for additional security and trust checkpoints in your IP integration process, please contact me with any questions.